Alright, this is Precalculus chapter 3.5, Inequalities involving quadratic functions. Let's get started. Alright, this is number 8. So we're going to solve this inequality. First, we want to factor it. So it will be x plus 5 times x minus 2 greater than 0. So if you set each binomial equals to 0, you got x equals to negative 5 and x equals to positive 2. So these are your critical points. You're going to put negative 5 and positive 2 here. And now we're going to test out the points. So I want to use negative 6, 0, and 3 and insert into the inequality and see what happens. So if you insert negative 6 in there, you're going to get negative multiplied by another negative, and this is going to be positive, so this is greater than 0. So the inequality symbol doesn't have an equal sign. We're going to be using parentheses. And this part is the interval we want. If you insert 0 in there, you're going to have a positive multiplied by a negative, and this is not going to be greater than 0. So we don't want this interval. If you insert the 3, then you're going to have a positive multiply another positive, and that's going to be greater than 0. So we want this interval as well. So your answer is parentheses, negative infinity, comma, negative 5, union, parentheses, 2, comma, positive infinity. For number 10, let's go ahead and factor out the x. So you got x times x plus 8 greater than 0. If you set each factor equals to 0, x is equal to 0, and x is equal to negative 8. So the critical points are negative 8 and 0. So I'm going to use negative 9 and negative 5 and positive 1 to test out the points. If you insert negative 9 there, you're going to have a negative multiplied by a negative, and this is greater than 0. So this part is going to be your interval. If you insert 1 into x, you're going to get positive multiplied by another positive, and this is greater than 0. So this is another interval that we want. So here is another interval. So your interval, you're going to write parentheses, negative infinity, comma, negative 8, union 0, comma, positive infinity. Let's go ahead and set one side equals to 0. So I'm going to subtract 6 on both sides, subtract 5x on both sides. So 6x squared minus 5x minus 6 is less than 0. If you use the quadratic formula, you're going to be able to solve for x is going to equal to 3 halves, and another one is going to be x equals to negative 2/3. And these are my critical points, so you want to say negative 2/3 and 3 halves. So the three values I'm going to be using are negative 1, 0, positive 2. If you insert the negative 1 in there, you're going to get 6 plus 5 minus 6, and this is not less than 0. So this is not the interval we want. If you insert the 0, you're going to get 0 minus 0 minus 6, and that's going to be negative 6, and that is less than 0. So this is the interval we want. So I'm going to put the parentheses saying that this is our interval. Let's go ahead and use the 2 and verify that that is not going to be our interval. So you're going to get 24 minus 10 minus 6, and that is greater than 0. So this is not the interval we want. So you're going to write negative 2/3, comma, 3 halves. For number 20, let's go ahead and subtract 40x on both sides. So you have 25x squared minus 40x plus 16 less than 0. If you factor it, it's going to be 5x minus 4 times 5x minus 4 less than 0. and then x is going to equal to 4/5. And I'm going to use 0 and 1 to test it out. If you insert 0 in there, and you're going to get a negative multiplied by a negative, and that's not less than 0. So we're going to put an x right here. That's not the interval we want. If you insert the 1, you're going to get positive multiplied by a positive, and that is not less than 0. So this is not the interval we want. So you want to say that the answer has no real solution. For number 22, let's go ahead and add 9 on both sides and distribute the 2 to each term. So you're going to have 4x squared minus 6x plus 9 greater than 0. If you use the quadratic formula, you're going to find out that x equals to an imaginary number. So that means that there is no x-intercepts, which means that we don't have any critical points. If there are no critical points, we're going to be testing out the inequalities with negative sign and positive sign. You don't have to insert the negative sign or positive sign into all the x's. Just go ahead and insert the leading one, the one with the x squared. You're going to get 4 times negative square, which is going to equal to 4 times a positive, and that's going to be positive 4, and that's greater than 0. So yes, anything towards the negative is going to be our interval. If you insert the positive sign in there, you're going to get 4 times positive square, and you're going to get positive 4, and that also is greater than 0. So everything towards the positive infinity is your interval. So your answer is going to be all real solutions. All right, that's it. Take care. Good luck with your homework.